What I have are the same species, western screech owls, in various stages of preparation. This is what they typically look like when they come in, your standard dead bird. And we always, whenever we get anything in, we always want all the collecting information about him. So this one, for example, was found dead along Highway 12 in Walla Walla. And if they're found dead along a highway, they are generally a roadkill. And this guy here what we do is, when we're preparing a specimen, is we skin the animal, and if it's a bird, if we're making what's called a study skin, the skull and the feet and the ends of the wing will be in the study skin. In this case, I was going to prepare this one as a skeleton, so I have just skinned him, and he still has his feet and his head attached to his body. But what I wanted to show is what an owl looks like when he doesn't have his feathers. If you've ever held a bird, you've probably noticed they don't weigh nearly as much as it looks like they're going to weigh, and partly because birds have to fly, and so they have these kind of hollow bones, and they're made to be lightweight, but also because they just have a lot of feathers. And especially a screech owl. Screech owls have to get through some pretty cold winters. So you can see that when they're next to one another, you can see that this bird is mostly feathers. And the other thing about birds, and this is true of pretty much all birds, is that they look like they have a thick neck, but they really don't. Almost all birds have this skinny neck, which they can move around a lot. You know, owls are famous for being able to rotate their head 180 degrees, but all birds, or most birds, have pretty flexible necks. And that's because one of the things that helps them to fly is that they have a rigid backbone. So unlike us, they can't curl up, and they don't have a lot of movement that they get from their back, but they have this pretty flexible neck that they can twist their head around, and they can clean their feathers, and they can tuck their beaks under their fur if they want to keep their head warm. And the other thing about owls is that owls have these really big legs and feet because they kill their prey by flying down and grabbing them with their legs. So they have to have pretty strong legs and feet. Okay. And then this is the skin of the owl. This body does not belong to this bird, otherwise he would have to have more than 2 feet. So in this bird, which is going to be made into a skin, all I've done is remove the body. I've pulled the brains out of the skull, but I've left the skull in so that the head has some shape, and the feet are left on, and the bones at the end of the wings are left on. So what I would do next, if I were preparing him, is to make him a little cotton body and put the body inside the skin and sew him back up. And then we would dry him out and put him upstairs with the collection. And this is what a finished owl looks like, and this is a study skin. So since it's a study skin, he's not really in a lifelike position. He's just stuffed with cotton so that you can fit him in a drawer, but you can see what his plumage looks like. The reason his eyes are white is that they're just cotton eyes. This is not a taxidermy mount, so we aren't using fake glass eyes or anything. And one of the things that makes a research specimen valuable is the information that goes along with it. So with this bird, of course, all of his information is on the tag that is with the body, but in the end, what they all get is a label, and the label has the location and the date, who collected it, and anything we measure, like his weight or length or whether it was a male or a female. Once you skin him, you cut open his body and determine for sure whether he's a male or female. You don't go by external plumage. You always want to make sure that what you're really looking at is a male or female. I would remove all of his innards except for and just leave the muscle tissue, because the bugs are very picky and they don't like guts. They just like dried muscle tissue. So I would dry him out in our drying cabinet for as long as it takes for him to get to be about the consistency of beef jerky. And right now what we have in the drying cabinet are some moose parts that are waiting to be cleaned. Like this. And most of what we do is not the size of a moose, which is why our containers aren't really all that big. But they're really great because they get all the little bits of tissue that would really be a pain to clean by hand. And I think we have a slightly bigger something or other down here. They like to work in the dark, so that's why they're kind of covered up. Oh yeah, this is, I think, a calf, a very young calf, domestic calf. And they're pretty much done with this. It's just about, it doesn't look like the finished skull. What we do at this point is take it out, wash it off, put it in peroxide to clean it up and turn it white. Upstairs, we talked about stable isotopes and genetics and techniques that when the people were collecting those animals, they didn't have a clue that we would be able to do these things in the future. And today, we have no idea what people are going to want to do in the future. So we sort of have this dilemma of trying to collect things that people might need or be interested in the future without having any clue as to what techniques they'll have available to them.